is the version, the kind of example that we're working on in class as a group, where we're trying to find time. So let's say how long hours would it take compromise 1010 steel so that 2 millimeters below the surface. The carbon concentration is 0.5% carbon. Assume the surface is maintained at 2, what's it, carbon and temperature is kept at 950 degrees C. So ten steel at 10 at the end means it's got C0 has 0.1 weight% carbon. And X is 2 millimeters. And that has to be in meters. 0.002 meters. And C, this is C sub X. Surface is maintained, so this is our surface concentration, CS. And the temperature, we need that in Kelvin. 23, 1223. And we'll use that temperature to calculate D, diffusivity. So that means we're given C0 and CX, and and CS. Those are the things on the left side of the equation. And on the right side, we're given X, and we're given temperature to find T. So the unknown is time. And you would be given, or by now you would know that T0 is always 2.3 times 10 to the negative 5 meters squared per second. And Q is 148 kilojoules per mole. This is true for carbon, confusing, in iron. So we can first calculate D. That's a good first step. D at 1223 Kelvin would be equal to 2.3 times 10 to the negative 5. And that's meters squared per second, e to the minus 148,000 divided by 8.31, that's R, and 1223. That's temperature. So that exponent should end up being negative 14.6. And e to that power is 2.11 times 10 to the, wait, no, that's not right. Need to make sure I use a negative exponent. Now, try, there we go. 4.74 times 10 to the negative 7. And so my value for D is 1.09 times 10 to the negative 13. Anybody get matching numbers there? All right, thank you. Okay, so we know D now. So our equation is CX.
We got, sorry, 10 to the negative 11.
This is negative 11?
Yeah.
Okay, oh yeah, that is 6. It's not 7. Thank you. That makes much more sense to me. And of course, that's meters squared per second. So the left side of the equation, Cx minus C0 over Cs minus C0, we know all of that, is 1 minus error function for right now, I'm just gonna call that error function Z. And then we'll define what Z is once we find out its value. So Cx was 0.5, C0 was 0.1, Cs is 2, and that's that equal. 0.21. Check that. 0.4 divided by 1. Yeah. So error function of Z, its value, will be 1 minus 0.21, which is 0.79. Seems like that we're in a frontier we haven't been in, but it's correct. Let's see. So hopefully you still have your homework 1. You can look at the error function table. We know the value of the error function is 0.79. And so we've got 0.7707 and 0.7970 here. 85 and 90. And if we rounded this, it would be 0.80, but it's still, I would say that's close enough. 0.79 is close enough to 0.7970 to say that Z is 0.9. Yeah, I don't think you need to interpolate there. All right, so what do we know about Z? Z was x over 2 square root dt. And now we know that that's equal to 0.90. And the only thing I don't know here is time. So the square root of time is equal to x 0.002 meters divided by 2 times 0.9 times the square root of 1.09 times 10 to the negative 11. And let's see, that 0.9, that doesn't have any units. The diffusion has units of meter squared per second. So I'll end up with units on the right side of the equation of the square root of seconds. So that jives with what I have on the left side of the equation. So I get square root of t equal to 337 root seconds. And t then 113. We'll just go ahead and include them all. 263 seconds. 31.5 hours. So if I wanted T to be smaller, I could try and use a higher temperature that would give me a bigger D value, or I could try and make X smaller. That probably is not a feasible, reasonable carbonization time. Anybody else get the same, roughly the same number? Okay, Jacob?
Can you solve for the exact number of Z just as an example?
Can I solve for?
The exact number for Z just as an example.
Oh, yeah. So if I were to interpolate, I have 0.79 minus 0.7707 over 0.797 minus same. That's equal to Z minus 0.85 divided by 0.9 minus 0.85. Just to check numbers here, for this whole thing, I'm getting 0.734. So, for doing the interpolation, I get Z is equal to 0.89. So that would make this 337 be a 340, which becomes 116, 135, 32.3 hours. So it's not insignificant. But it would be okay for me. That amount, that difference in values for Z, that would be okay. All right, so I'd like you to kind of group up in groups of 2 or 3. I kind of did that. Okay, so Diane, you want to come down here and you 3 work together? And Tyler, can Tyler? Oh, you too?
Yeah.
Perfect. Okay, then you too. Tyler and David,